Okay, let's begin. So, alright, focus. We're gonna main order of business to get through this today. Hopefully you tried it on your own. Hopefully you got it. Alright, let's begin. Focus, focus. Come on. Problem 1. A is 1, 2, 2, 1, 0, 1, 1, 2, 1. Find the inverse. How do you find the inverse? Yeah.
You augment it with the identity on the right, and then you do row operations until you put the identity on the other side.
Yep. What's the first step? Yeah.
I did row 2 minus row 1.
Okay.
And then I also did row 3 minus row 1.
For the other 2 lines?
Yeah.
Yeah.
To get
That would work. I'm going to also move row 2 to row 1. Why? Because it has the 0 here, which I know I'm going to need eventually. So I'll probably use that as well in the first step. Move row 1 up here. And then, yeah, you can use row 1 and row 2. Let's do row 1 minus row 2. This minus that, 0. This minus that, 2. This minus that, 1. This minus that, 1. This minus that, minus 1. This minus that, 0. And then we can do row 2 and 3. 0, row 3 minus row 2.
Yeah.
This minus that, 0. This minus that, 2. This minus that, 0. This minus that, 0. This minus that, 1, minus 1, this minus that, 1. And we look like that in the first step. Pretty nice. We have that pivot sitting nice right there. We're going to get one right here. He always has the 0 above him, so we just need to kill that too. So in the next step, I would probably actually do just that. So I would leave the first row. For now, I'd also actually leave the second row. Row 1 and row 2, I put them back. And then here I'm going to take row 2 minus row 1. Oh, in fact, you know what would be nicer? You guys see it? Move row 2 up here. I'm not going to divide by 2 just yet because I don't want any halves, but he also has a 0 in a very convenient position. So I move row 3 up there, then do this. So 0 minus 0, 2 minus 2, 1 minus 0, 1 minus 0, minus 1, minus a minus 1, 0 minus 1. So we have that. The only guy that's the problem now is this one right here, which I can just take row 1 minus row 3 to get that done. So 1 minus 0, 0 minus 0, 1 minus 1, 0 minus 1, 1 minus 0, 0 minus 1. And to fix this guy, just divide through by 2. And this guy's already fine. And so that means that your A inverse is this guy. Did everyone get that?
Yeah.
For the third row, the first I don't understand how you get the bottom one with R2, and the second one's O2, 1, and then minus R1 is 101. So I don't get where.
Oh, this is 3.
Okay.
Yeah, sorry about that. I'm taking this one minus that one. Did anyone get that? Did anyone get it after 1, 2, 3 steps?
Yeah.
4? 4 is pretty good. Anyone take longer than 4?
I'm on 8 right now.
Yeah, you don't want to be at 8.
I don't like this. For that, you did 3 steps, you won.
Okay, yeah, I write it out.
I read it all the way out.
Smaller steps, yeah, because I
Yeah.
get confused.
Okay.
Actually, no.
But did you get here eventually?
I'm on the way. Yeah.
Yeah, you might want to do it a little faster. One thing is, yeah, you might slow things down so you don't make a mistake, but you also should be aware that the longer you spend doing this, the more opportunity there is for you to make an arithmetic error, right? Like, there's only so many mistakes I can make in 3 steps, but if I'm at 8 steps, like, there could be tons of mistakes all over the place. You don't really want to end up in that position like that. So you really want to be efficient. Like I said, you want to make the game focused on the pivots. You're worried about getting this one first, 0s below. Then you get this one first, 0s below. Then that one. Then you start working on 0s above. Every now and then I might see an opportunity to get a 0 above without much work. I do that. So I swap these two because I know it'll give me a 0 here where eventually I'll need it. And there came a point where I swapped these two because I know I'll need a 0 here eventually. And so I can get it kind of for free. So you want to look at things like that. You really want to know my pivot should be here and my 0 should be here. What is the quickest way to obtain that situation? Legally, anyway, using only one of those 3 things. So that would be the inverse. And now it says in part 2, use A to solve this system of equations. X plus 2y plus 2z equals 1. X plus z equals 1. X plus 2y plus z equals 0. And what you would notice here is note A in part A is the coefficient matrix of the above. And since a inverse exists, right, because this is 1, 2, 2, 1, 0, 1, 1, 2, 1. It's the same guy here. And we already saw that if AX equals B and A is invertible, then we know that our X, which is X, Y, Z, is going to be the inverse times the guy over here. I'll just repeat that. So it's going to be minus 1 times 1 plus 1 times 1 plus 1 times 0. Then a 0 times 1 plus a half times 1 plus a half times 0. Then it's going to be 1 times 1 plus 0 times 1 plus minus 1 times 0. I think that looks fine. So this would be minus 1 plus 1 is 0 plus 0 is 0. 0 plus 0 minus a half. And 1 plus 0 plus 0 is just 1. So that should be my solution. At this point I'll check. Just need to make sure. So if I plug in 0 for x, minus a half for y, and 1 for z, that is minus 1 plus 2, so that actually checks out. If I plug in 0 for x and 1 for z, I get 1, so that works. If I plug in 0 for x, minus 1 half for y, and plus 1 for z, that's minus 1 plus 1, that's 0, so that works. So that's the actual answer. Now, if I came here and something didn't work out, I would first check this multiplication here, which again, notice that I was writing down in a pattern. 1, 1, 0 is always in the parentheses. And the rows of my inverse matrix are going across here. Minus 1, 1, 1. 0 minus a half. 1, 0, minus 1. So I would quickly check that. If everything looks good there, it means I made a mistake before, and that's what these things are going to help me do. So I'm going to just quickly run over what I did here and see, okay, what was I thinking about at this point? Oh, I was dividing this by 2. Do I actually get all that? Yeah, okay. And so you kind of use these breadcrumbs to kind of guide you, and you'll see where you made a mistake. So yeah, that's problem 1. Yes?
How come yesterday when we did the inverse, like you put 1/2 in front of it?
I could do that. There's no, it's equal. So you could have thought of this as, because we had like a lot of halves all over the place, I just didn't like writing that. But you could factor out a half and write this as minus 2, 2, 2, 0 minus 1, 1, and 2, 0 minus 1. This is also a code.
Oh, and if we use that multiplier,
And if you multiply this by that, and
It's-
then multiply each part by a half,
It's still going to
you'll
get-
still get.
oh, okay. I thought the 1/2 was like a necessary step for everything.
No, it's because we had a bunch of halves here. I just factored it out so I can
Oh,
write
okay.
whole numbers. It was more for aesthetic reasons. Than
So we could leave it just as.
either way, it's fine. Yeah. Other questions about this? So pretty standard problem. I'm giving you a problem like this on the first test, so it's coming up. So I'm just gonna say it right now. It's gonna be a 3 by 3, and I'm gonna ask you a question like this. So try to get through it and try to be efficient when getting through it. Like here, the one I give you on the test, it should be like 4 or 5 steps. If you're taking much longer than that, something's off. Okay, 2. Find the reduced row echelon form of this matrix. 1 minus 2, 3 minus 2. Let's do this again. What do we want to do here? Well, that guy's already in a nice position because he has the 1 here. So to be efficient, the very next thing I do should give me a 0 here and a 0 here. That's the goal.
Do you not draw the bar in between the third and fourth?
It wasn't drawn here.
Yeah.
You don't have to.
You don't have to?
Yeah, the bar is more for you to imagine where the equal sign is. And, but this is, yeah, so here, to get a 0 here, what's a nice way to do that?
R2 plus R1.
I can add these two to obtain 0 there. R1 plus R2. So this plus that, 0. This plus that, minus 1. This plus that, 1. This plus that, 1. So that gets me the 0 here. Another nice way to get 0 here.
You could do row 3 plus row 2.
Yeah, 2 row 2 plus row 3. So it's this plus 2 times that, 0. This plus 2 times that, 1. This plus 2 times that, minus 1. This plus 2 times that, minus 1. Now I know I want to make this guy a pivot and get zeros below him. For now, I'd leave row 1. Here I can just multiply through by minus 1. And then for the last one, I can add these two to get the 0 here, because I know I want a 0 here. So I'm going to take row 2 plus row 3. This plus this, 0. This plus that, 0. This plus that, 0. This plus that, 0. Okay, so we end up with all zeros. Not reduced row echelon form yet. What's the issue? Yeah.
-2.
Negative 2 is a problem. We need that to be a 0 for this to be reduced row echelon form. So what can I do to get that to happen? Yeah.
R1 plus 2R2.
R1 R2. So this plus 2 times that, 1. This plus 2 times that, 0. This plus 2 times that, 1. This plus 2 times that, minus 4. And then this row is fine. And they're all zeros here. So that's the reduced for echelon form. Any row of zeros is at the bottom. First non-zero number in any row is a 1. Those ones have zeros below them. They also have zeros above them whenever possible. So that's reduced row echelon form. Again, 3 steps. Shouldn't take you much longer than that. Like if I write a problem where it has to take you a long time, I'm gonna have to grade it. I'm not gonna sit here like watching people do things like 10 matrices later. I'm gonna give you something 3, 4, 5 steps. If you're taking longer than that, you're probably not being efficient or you're undoing things that you already did. So in B, it says, hence solve this equation. This system. And then what you'd realize is if I ignore the variables and the equal sign, the augmented form of that is this. So that's where you say, oh, now I can imagine that there's something here. So that's on the other side of the equal sign. And so now I first assess this. Is it inconsistent? The answer is no. The only way for that to happen is to have a bunch of zeros and a non-zero number. So there is some solution here. Notice that there are 3 columns in the A, and there are only 2 pivots, which means I know there's not a unique solution. There has to be infinitely many solutions. So what I'm going to do is to find the guy who does not have a pivot in this column. So remember, this is the X column, this is the Y column, this is the Z column. Notice the X has a pivot, the Y has a pivot, the Z does not have a pivot. So I set Z to be my free variable. He's the guy I can't solve for. And so now I pretty much want to solve for everyone else in terms of him. So from row 2, I would see that y minus z equals minus 1. This means that your y is equal to z minus 1. And in row 1, I would see x plus z equals minus 4, which means that my x is going to be minus 4 minus z. And that's our solution. You can write x comma y comma z. I'm writing it in a different way because in your online homework you might have to express it this way. They might have you write it as a coordinate like the following. So minus 4 minus z comma z minus 1 comma z. And they might tell you to say something like z is a real number. So this represents an infinite number of solutions. For every real number I put in that position, I get a new coordinate that will actually solve the system. And one way you can check, if you plug in this expression into that, all the equations should work out. But probably a very quick check if you don't want to spend too much time on this and you're rushing, is just plug in a particular value for z and check if those numbers actually work. So, like, if I plug in z equals 0, that should be easy to check. That means my x is minus 4, my y is minus 1, my z is 0. So this would be minus 4 plus 2 plus 0, that is minus 2, so that works out. Minus, this is positive 4, minus 1, that's positive 3, and minus 0, that's that. Here, if I plug in minus 4, this gives me a minus 8, plus 1, that's minus 7, plus 0 is minus 7, so it actually checks out for that one value. Now, it doesn't mean it will work for everything, but that's usually a good check. If you just plug in a random point, and chances are it's gonna be the right answer. That's just a quick check. But even if you were to plug in minus 4 plus z and plug in z minus 1 here, and plug in z equals itself, that will actually work out to -2 and etc. So that's actually the solution. All coordinates that look like this will solve this system as infinitely many solutions.
Yeah, 5 row of zeros, you're gonna need a free variable.
Assuming that the number of pivots is not the same variables. Because you could end up with a situation like, and then an extra row down here. That one has a unique solution, so you won't have a free variable in that case. So to determine whether you should have a free variable or not, it just means you just check for each variable. Does each variable have a pivot in its column? If the answer is yes, it's a unique solution. If the answer is no, then whoever does not have it gets to be the free variable. So that's how you want to do it. So that's the answer to problem 2B. Okay, so problem 3 is a word problem, and it's a huge one. So let's actually look at that. Or maybe let's build up to it. Let's do problem 4 first, because that's also a word problem, but it's going to yield a much smaller system, and then we'll tackle problem 3. Let's build up some nerve here. So let's do 4 first. So this is a very simple supply and demand kind of situation, which you kind of know about supply and demand. Have you seen? So yeah, so at 480 per barrel, a nice way to visualize this, I would say we can even do a little sketch here. Not totally necessary, but I think it helps visually. So what we are going to do is like put price down here, and we can do either or here. Versus, I'm going to plot them on the same axis so we can notice something. So supply, let's do it in green, or demand, let's do that in pink. Okay. So let's actually start reading this. Okay, so at $4.80 per bushel, the annual supply is going to be 1.9 billion. Okay, so what we're going to do, they told us about a price, 480. A second price is also mentioned, 510, that's going to be over here. So what's going on at 480? Well, the supply is 1.9 billion. So I'm going to have a point here which says 1.9. That's for the supply, and so there's going to be that point on the supply equation. The annual demand is 2 billion, so I'm going to put in a 2 here, and that's going to be the one for the demand. Now if you don't have colors, just put like a dot for one and then X for the other. You do want to distinguish between who's who. Okay. So when we're at a price of 480, the supply is 1.9 billion and the demand is 2 billion. When we increase the price to $5.10, the supply also increases
To 2.1.
to 2.1. Well, it's 2.1 over here. But the demand decreases to 1.8. Assume the price supply and price demand equations are linear, which means these guys are connected by straight lines. So we have that kind of picture. which fully falls in line with the law of supply and demand that we know of, basically which says the supply equation will increase as long as price increases, while the demand equation will decrease as long as price increases. So that's kind of very expected here. Because of course you can always argue that a supplier is willing to supply more product if he can charge a higher price for it. And so you can say, well, if I'll pay you $5 for an iPhone, how many iPhones can you make? Like one, I'm busy with the kids and what. Okay, I'll pay $1,000 for every iPhone. I will have 5 million of them for you by this weekend, right? Your suppliers are willing to produce more for higher prices. However, once you start raising the price, less people buy them, so less people demand them. So a demand equation will tend to decrease over with respect to price. Supply expects to increase. Now, what is this intersection here?
Equilibrium.
Right, that's what's called the market equilibrium. Right? So, if you're before that point, what will happen is people are going to want more of the product than people are willing to supply the product. If you're beyond that point, now we have excess product, not enough people buying them. So now it's a situation where you have scarcity on one hand, and here you have overabundance. Pretty much the sweet spot is going to be the equilibrium. At this price, whatever it is, question mark, that's where the amount of products in the market is going to be equal to the amount of people willing to buy those products in the market. So that's always a nice thing to figure out. So this is a very simple situation where we are going to examine demand and supply and what the equilibrium is. Now, because these guys are linear, it means that the equations will look like straight line equations, y equals mx plus b kind of thing. So, and that is in fact part A and B. Find the price supply equation. That is the green line. I want the equation for the green line. And part B is to find the price demand equation, which is the equation for the pink line. But we have 2 points, so that should be enough to find the equation of the line. So A. How do you find the equation of a line that goes through 2 points? Well, first you can call the point something, right? So let's say you call it x1. y1 is the 480, comma 1.9. And then your x2, y2 is going to be the 510, comma 2.1. We know that the slope is going to be y2 minus y1 over x2 minus x1. So that's going to be 2.1 minus 1.9 divided by 5.10 minus 4.8. And what's that? 1.5? So that gives you 1.5. And so now you can actually use either one of these points. Y minus y1 equals m, x minus x1. So you have y minus, let's use a 1.9, equals m, 1.5, x minus the 4.8. So you would have pretty much y equals 1.5x minus 1.5 times 4.8. Plus 1.9, and this one looks something like, well, what's that? What's this? Or do 1.9 minus this number, what do you get? So put 1.9 minus, open parentheses, 1.5 times 4.8, close parentheses. What do you get?
I think the slope is 2/3.
Here? What is it? As a decimal?
0.666.
Oh, it's exactly 2/3, like 2 over 3? Oh, let's actually just use that. So So it's like, yeah, 0.666666. Okay, so that would give me this, 2/3. That would give me this, 2/3. Okay, so 1.9 minus, open parentheses, 2 divided by 3 times 4.8, close parentheses. What do we get?
If I like did my coordinates like differently, like I did 1.9 comma 4.8, does that change the answer? Like I had my quantity on the y-axis, on the x-axis.
It will change your answer, but it just, you will actually have things flipped.
Okay.
So as long as you know, in your mind, your x is really the supply
Okay.
and your y would be the price. That's kind of, so technically there's nothing wrong with it as long as you know which variable is measuring what.
Okay.
But it's very traditional to have the price on the horizontal. I usually think of the price as the x coordinate. But as long as you know which variable is measuring what, that's what's important. So once you write down your final answer, the price is this, you know you're not writing out the x coordinate, you should be writing out the y. So as long as you keep track in your mind of what you're measuring. So yeah, for me, I'm using the x coordinate to measure the price and the y to be the supply. And then I'm going to use the x coordinate to measure the price and the y to be measure the demand for the pink line. So yeah, what do we have here?
1.3.
1.3?
Yes.
So what I can do then is I can write this as 2/3 x minus y equals 1.3. So I move the y on this side, the 1.3 on that side, and I don't really like the fractions. So what I could do, I know multiplying this by 10 will move the decimal point over, and I know multiplying this by 3 is going to get rid of the 3 in the bottom. So what I'll do is I'll multiply everything by 30, right? Not completely necessary, but just to make the numbers nicer on myself. So I can do this. So 30 times this, that will be 20x minus 30y is going to give me, what's 30 times this? So 10 times that is 13, what's 39? 39. So I can have, this is my supply where y is the supply at price x. And now we want to repeat this for demand. So we're going to go in and do the same thing. So here I'm also going to use 2 points, x1, y1, x2, y2. First price is 480, second price is 510. What happens with the 480? The demand is 2 exactly, and at 510 the demand is 1.8. So my slope is going to be y2 minus y1 over x2 minus x1. What's that?
Yeah, negative 2/3.
Minus 2/3? You agree? Let's get some consensus here.
Yeah, that's okay.
Okay, alright, so now I'm gonna go plug in y minus the, pick any y coordinate, let's pick the 2 because it's nicer. Equals minus 2/3 x minus 4.8. So this means that it's gonna be y minus 2 equals minus 2/3 x plus 2/3 times 4.8. And so can do, move the x over here, 2/3 x plus y equals 2/3 times 4.8 plus 2. And what's that number? So parentheses, 2 divided by 3 times 4.8, close parentheses, plus 2.
5.2.
5.2.
5.2.
Okay, so I would again multiply this by 30. Again, and this is not completely necessary, but it's just to make the numbers nicer on myself. Multiplying this by 30, the 3's cancel, I just get 10, so I get 20x plus 30y equals, this would multiply, I get 52 times 3. What is that? 156?
Yeah.
And so that's the demand equation. So this is the demand Y for price X. Right, so as long as you might have done the coordinates the opposite way, just make sure you know which variable is measuring what. So we have those two equations. Let me actually copy them down right on this picture. So here this is 20x plus y equals 156. What was this one? 20x minus 30y?
Minus 30y equals 39.
39. Okay, so those are my two equations. So that is parts A and B. Part C, find the equilibrium price and quantity. So what does that mean? I want to find where these two lines intersect. How do we do that? Solve the system of equations. So essentially what I'm going to have is I have someone who's like 20, so I'm going to C3. So looking at the coefficients here, 20 minus 30, 39. Coefficients here, 20, positive 30, 156. I want to solve that system. One thing I can do is leave this guy. Maybe I'll put the 30 here. 156. What I can do is say take equation row 2 minus row 1. This minus that, 0. This minus that, 60. This minus that, 156 minus 39.
117.
117. So I don't have to bring this to reducer echelon form because that's not the point. What I can say right away is that 60 times the y is 117. So my y is 117 over 60. Does that reduce to anything nice? No, you can go into 117.
It's 1.95.
Some of the digits is 9, which is divided by 3. So 117 is
1.95.
1.95. And so the x now, so I would have 20 times x minus 30 times 1.95 equals 39. And from that I can solve for the x. So my x is going to be 39 plus 30 times 1.95 all over 20. What's that?
This is the one that we wrote some stuff from last week. We're gonna figure that out.
$4.875
4.87
and then 5.
and 5, so let's round it to 4.88. So that's the best price. This supplier should price their product at 4.88, $4.88. and at that price, the consumers will demand 1.95 billion products. But the supplier can reasonably assume that all of that production will be sold. Like people will buy it at that price. Which, a part of it when it comes to figuring out what price you want to sell something at, a part of it is actually doing this kind of research. So someone who's coming up with a product, what they do is they will sell it to different stores, but they sell it at different prices. So they're like, okay, over this store over here, they're selling it for $4.80. But if you drive to that town over there, they're selling it for $5.10. They realize that, okay, where I'm selling it for $4.80, this is how much people are buying it. But on the other store, this is how much people are buying it, right? And then they kind of figure out, well, they figure out then what they're willing to do it for, and they kind of find the intersection. And of course, you'll have multiple points. So you don't just have two. You're not gonna. It's not market research to check out two positions. But you'd have multiple points where you kind of do this, and then finding the intersection is going to be where you want to fix the price at. So if you're going to sell on Amazon, where there are people from all over the country, $4.88 is probably what you want to do. You can pretty much be guaranteed to sell 1.95 billion there. Yeah, I don't think we'll get to the third one. But try that again. I guess we'll finish that next time, and we'll start something completely new, which I think is going to be fun. You don't get to do it all. Like finding quizzes is blind. You do this all the time. Boring.
Thank you.
Okay.